Hello, my name is Caroline, and my partner and I, for our project Gold Point premise, it's an animation that basically supports elastic collisions of planetary objects, such as the planets and the sun, as well as any other objects that's in the system that we wanted to put. So originally we were going to support movement of the rocket or the other objects via the 4 arrow keys on the keyboard. But because we had a bunch of issues with technology and from my computer breaking on Friday to us being unable to pull from our shared repository multiple times, we decided not to include that part for now. So for the demonstration, before seeing the actual project, we'll run a simulation on the Armageddon.txt file, which is the system that we're going to run our planet in. So to see what the planet will be like, we will run it right now. So as you can see right now, the planets, they're rotating around the sun as they would normally, and we see there's a ring of little squirrel-like items around the edge along with one giant squirrel, and they have the same mass. So it's just that giant squirrel didn't get its size reduced, but now we can see it's starting to go off a little because of the spiky little thing that's coming around, and the mini squirrels are being drawn to it. And if you look carefully enough, you can see that they're being spun inside the little spiky ring in a circle because of gravitational pull and the rotation forces, which kind of slingshot it around and then shoot it off into space. So we accomplished this by writing a vector extreme class, which kind of determined the way in which the squirrels would behave around certain planets, and to make our lives easier when we were determining what would orbit and what would slingshot. So you can see the giant squirrel, it keeps rotating around what I believe is Jupiter, and it's getting faster and faster and going opposite direction depending on what other forces come into play. But as you can see, the spiky thing and the sun just slingshot each other off into the opposite direction, but the squirrel is still rotating around because Jupiter is still there. And now, as there are fewer objects in the solar system that we see that everything just floated off and dispersed. So how did we do that? We wrote the NBody class or extreme class and the body extreme class, and basically what we had to take into account was the bouncing off of other planets based on sensing whether they were close or hitting another planet or not, and as well as its increases in magnitude of velocity and whether the planet would stay in rotation or whether it would slingshot. We decided to consider only purely elastic collisions because the physics of this entire system isn't 100% correct, as we can see here. So it wouldn't be very logical for us to make sure that it would entirely be physically correct. So now we have finished the simulation, and if you can see, everything got printed out here as it should, and we can see that everything has ended. So as each celestial object bounces off each of the other objects, the velocity does change. So for the bigger ones like the Sun, the Mars, Earth, Venus, and Mercury, their changes in velocity were very small when the giant asteroid came in and when the squirrels were bouncing off of it. And when the squirrels approached any of the larger ones that weren't supposed to be there, you can see that it increases velocity extremely well, and it would just shoot off into infinity. And this is because the difference in mass of the two objects are so different that if you take into account the momentum equation, P equals m times v, P being the momentum, m being mass, and v being velocity, we know that if there is a larger mass, then the velocity will decrease, and if the mass is smaller, then the velocity will increase. Because the change in, or the two momentums, the momentum is equal and opposite for the two objects. So when they bounce off each other, one will go in one direction, the other will go in the other direction. So thus we can observe any of the squirrels flying off the screen shortly, but the planets will continue to circulate until there are other forces at play that will change the direction of orbit, and they start affecting each other. So that is the extent of our CS61B gold points for Project 1. We hope you enjoyed watching the squirrels flying off the screen as well as everything else. Thank you.